Yeah, hello students, welcome back. As discussed in the previous video lecture, before the final exam we have to finish chapter 5. So until now we have covered from chapter 1 to chapter 4, and now I will in couple of few video lectures I will finish chapter 5. But I noticed that most of the students, they are not watching the video lectures on regular basis. So please go through all the video lectures for better understanding. So in this video lecture I will solve problem 5 of chapter 5. The statement of the problem is that a hauling truck is traveling on a level road. The driver suddenly applies the brakes, causing the truck to decelerate by an amount g/2. This causes a box in the rear of the truck to slide forward. If the coefficient of sliding friction between the box and the truck bed is 1/3, find the acceleration of the box relative to truck and relative to the road. So the box in the rear of the truck, as mentioned in the problem, when actually the truck is traveling on the level road, when the driver applies the brakes, the box in the rear of the truck, it slides forward. The box is getting only a frictional force of u mu mg. Actually this u, it is given in the problem like this u. It is the coefficient of sliding friction between the box and the truck bed, and its value, it is given in the problem, its value is 1/3. So here you can see that if assume that if this is the this is the truck, and it decelerates when the driver applies the brake, it decelerates by g/2, and this is the box in the rear of the truck, and its frictional force, actually when driver applies the brake, so it also moves forward, it slides forward, and its frictional force is umg, this one. So as mentioned, the deceleration AD, it is equal to g/2, like here. The first part of the problem is that we must find the acceleration of the box relative to the truck. So for that, our equation will be like that: F is equal to MAD minus frictional force, this one. So here we know that this F is equal to MA, which is equal to MAD minus mu mg, because here F is equal to mu mg. So actually this is U, so F is equal to umg. So this is just a simple simplification. We will cancel the m from both sides, like this one and this one, and the remaining equation is A is equal to AD minus UG. This is equation 1. So now we will plug the values of deceleration AD and U in equation 1. This is the U. So as mentioned in the previous slide, the equation 1 is this. So by putting the values, this is the value of AD and this is the value of U. So our equation will be like A is equal to g/2 minus 1/3 g. So after simplification we will get that A is equal to g/6. So here we will assume that g is equal to 10 meter per second square. So finally A is equal to 10/6 meter per second square. So this is in opposite direction of the deceleration. So this acceleration is in opposite direction of deceleration. So this is the first part of the problem. In the second part, it actually in the second part of the problem, we must find the acceleration of box relative to the road. So in the first part we found the acceleration of the box relative to the truck, and in this part we have to find the acceleration of the box relative to the with respect to the road. So in this case only F is the real force acting horizontally. So our equation now it is more simple here. Ma is equal to minus F, and you know that the acceleration relative to the road is A is equal to minus F over m, and which is equal to, we will just put the value of F, which is umg. So this term is equal to minus umg over m. So this m will be cancelled out with the denominator. So finally our equation is A is equal to minus ug, and we know that this u is equal to 1 over 3. So finally our equation is A is equal to minus g over 3, and g is equal to 10 meter per second squares. So acceleration A is equal to minus 10 over 3 meter per second square. So this term A is equal to 10 over 3 meter per second square. So this is the unit. It is the direction of deceleration, and you can see actually here it should be the negative value. Yeah, so this is all about problem 5.5.